Welcome to week 4, and in week 4 we are going to talk about streams and groundwater. In particular, these topics, things that we're going to talk about, for streams we're going to talk about kind of the basics, major characteristics, parts of a stream, then we'll get into how a stream erodes, transports, deposits sediment, and the major stream types. How do you tell the age of a stream, the landforms that are created? And I'll talk a little bit about some of the hazards as well, kind of as we visit each type of these different streams. And then when we talk groundwater, I'll talk about how it moves, what is it, some of the different landforms that are created by groundwater erosion, and then what aquifers are, the major types, and some of the hazards associated with groundwater. So to get started with streams, in this video we're going to talk about major characteristics and some of the parts of a stream and stream flow. One of the first things to know and be familiar with, if you aren't already, is the water cycle. And streams fit in nicely, as well as groundwater and glaciers that we're going to talk about next week, to this whole cycle. So we're going to be talking about the surface flow part of the water cycle. We get that surface flow for two reasons. One reason, because of rainfall, precipitation falling on the surface of the earth, or snow melt running off of the surface of the earth, filtering into those streams, but also that stream is also connected most of the time. Some streams aren't, but most streams are connected directly to the groundwater table. And we'll talk more about that interaction when we get to groundwater. So some of the kind of basic stream information that you might need to know. Well, the term stream isn't necessarily the only term to use to identify a body of water that's flowing from point A to point B. A lot of people call them rivers, creeks, brooks, runs. So all of these kind of encompass the same thing. And the name Columbia River versus a stream somewhere doesn't necessarily mean that the river is bigger than the stream. A lot of times people get these geographic names for a body of water that really sounds good and not necessarily describes exactly what it is. So basically what a stream is any surface whose flow is confined to a channel. So we have a linear, might be somewhat sinuous, but it's going to be a depression in the landscape that water collects and then flows in the same direction down slope. So we're going from a higher point to a lower point through whatever topographic low there is. And this can change. So if we have increased erosion in one area, a stream can actually jump its channel and move to a new spot. The Mississippi River tries to do this whenever it floods, but it's so channelized, it's artificially kept in the current river channel by concrete barriers. It wants to jump out of that stream and go a different way, but we keep it there because we need the Columbia or the Mississippi River to flow through New Orleans and past all of the ports that that exist in that area. So there's a lot of infrastructure that we don't want to end up high and dry and have to rebuild. So this other idea is this thing of base flow, and this base flow basically is what enables a river to flow between storms and through droughts. And base flow basically is the water that's coming from groundwater. Or, in our case around here, our base flow is directly related to the glacial melt. So if all the glaciers were to disappear on Mount Hood, the Hood River would eventually probably dry up. There may be a little bit of water, but it would definitely not flow the way it does now if that glacial meltwater wasn't supplying it all summer long. So some characteristics of stream flow. There's a few different things that we measure. The velocity, so how fast the water's moving. the gradient of the riverbed, so that's basically the steepness of the riverbed, and that is calculated through rise over run. So you figure out difference in elevation between 2 points, and then the horizontal surface distance between those 2 points. And then the discharge, which is the volume of water that flows past a given point in a given amount of time, and that's usually measured in cubic feet per second. And here you can see one of the measuring tools that geologists use. There's a lot of major river gauging stations. They'll have one of these rulers kind of set up that measures. It's an easy kind of quick glance. Okay, this is how deep the water is at this point. It's at flood stage, it's not at flood stage. And a lot of times these areas, they have more electronic devices to measure that as well. And this website that I want you guys to visit, NOAA River Observations, it's pretty cool. You can visit that website and see, let's pull that up here, a map of the U.S. And here it is. So we see all these little green dots all over the United States, and some of them are purple, some of them are red, some of them are yellow. Well, what that means, if you look over here on the right, the color corresponds to what's happening at that site. So green indicates normal conditions, no flooding. All the way up to purple would be major flooding, and anything between green and purple would kind of be increasing the amount of flooding. And then the grays are out of service or old observations. So when I looked at this last time, we took a look over here at the Hood River, and we can kind of zoom in to these different areas. When you zoom in, you see we can actually look at the Deschutes River if we wanted to, the Hood River. We'll take a look at the Hood River, and you can see that when we click on it, a graph pops up, and there's two things that you can see here. The blue dots that you can see are really close together. Those are actual measurements at a certain gauging station on that river, and it's actually that gauging station is located, if I go back, directly where I clicked. So that gauging station is located exactly at that point, which is pretty cool. And you can see on Tuesday, it was kind of the tail end of that rainstorm that we got. You can see that the river flow is kind of decreasing because we don't have as much rainfall, and it's returning back down to closer to base flow. And you may know it's supposed to rain this weekend, so Saturday and Sunday, and it's going to actually increase. This is predicted, the purple over here, so they know what the weather is going to be like. They know it's going to rain, so they're saying, okay, if it's going to rain, that means our river discharge is going to increase, because that river channel is in charge of diverting all of that water down into the Columbia. So if you guys are interested in checking this out, you can view it and see this weekend if it actually does increase as much as they've predicted. And so everyone knows, if you look at the date up here, this is from October 19th, 2012. So if you're looking at this in 2013, you might have to look at historical data for this. But it would be interesting to see what's happening the exact date that you're watching this video. Go to that website and view the Hood River or whatever river is nearby you. Look at the weather and see if things are being predicted, and then see if those predictions come true. So the relationship between these different characteristics, the velocity, the gradient, and the discharge, basically the steeper the gradient, so the steeper the slope, faster the water is going to go, and the greater the discharge, because we're moving a lot more water through a given point. So we're having a higher volume of water flowing past that same point in that same amount of time. And so here we've got that graph. This is from a few days ago. You can see here this would be where we were viewing the data from the current data on the 19th of October, and I printed this graph out on the 15th of October, and you can see That's right when that rainstorm hit, and they predicted that the discharge would increase dramatically and then taper off, and that's what we saw. We saw that tapering off here in the October 17th to 19th. Now in some places you might notice here we've got this kind of yellow bar up on the top. Now that is indicating some of the minor flooding, and if you look over here, this is different location here. If I make this a little bit bigger for you to see, this river is actually showing it's in the low flooding, moderate flooding zone, and then the yellow is minor, the red's moderate, and the purple's major, and you can see it corresponds to specific feet, and that's telling you how much that surface flow of the river is going to increase to make it moderate flooding or major flooding. So sometimes when the river flow gets high enough, you might start to see these color bands so that you can see, okay, is it predicted to be major flooding or moderate flooding? What's going to happen? Which is pretty neat, pretty interesting data. So what are the parts of a stream? Well, here's a map showing you the Klamath River. It stretches through California and Oregon. There's a few different things here. Now this whole green blobbed area is showing you what's called a drainage basin. The line, the very edge of that green blob, is showing you where that drainage divide is. So basically what that's saying is any water that falls inside this green blob is going to flow or end up in the Klamath River and flowing out the Klamath River in California into the Pacific Ocean. So that's what it's called, a drainage divide. So any water in this blob is going to end up at this point right here at the mouth of the Klamath River. With that mouth of a river is where that river empties into another body of water. So in this case here, the Klamath River is emptying into the Pacific Ocean. So the river mouth will be right at that boundary. And this is where features like deltas form. And we'll look at those in the next video or two. We also have what are called tributaries. So the Willamette River, or sorry, it's too small for me to see here. The Lost River, Trinity River, these are all what are called tributaries to the Klamath River. They all flow into the Klamath River. And then where we have those rivers, those tributaries starting way up here, they're usually higher elevation, and we call those the headwaters of the river, so where that water begins. So when we get a major storm, if maybe we have a major rain event, it only hits parts of Oregon, it doesn't hit parts of California, we only get that rainfall up here. The water level down here at the mouth is still going to be affected by what happens upstream, because all this water is going to filter down and end up at the mouth. So even though it's not raining down here, you can still get an increased volume, an increased discharge when it's not raining if you've got major rain happening upstream. So you can see that on the Hood River sometimes if it's not raining in Hood River, but it might be up on Mount Hood. That's a sign that, hey, we've got a rainstorm happening up there, the water level is pretty high, so you still need to be careful. So in some places, especially really dry areas, it's important to know what's happening around you, because you can get what are called flash floods, which come down from a higher elevation area where there's been a rain event, fills up those river valleys, increases the discharge, and then flows downstream into these areas that are normally pretty dry and hasn't rained. So it can be a pretty big surprise sometimes. So that's kind of the basics of streams. We'll come back and talk about how streams erode, transport, and deposit sediment.